Hello students, today we are starting our lab microcontroller and embedded system laboratory 18CSL48. Before moving to the program, we should know what is directive. Assembly directives, these are not instruction but these are allocating space and define types in many instructions. You can find some of directives which we will use normally in the program. First one, area. This directive is used to make a new block of data or code. Next is entry. This is the entry point of the program. Align DCB. DCB it allocates 8-bit data. DCW it allocates 16-bit data. Means half word. DCD it allocates 32-bit data. Space, fill, equal, export, input. All many types are there. You can see this one PROC. It calls the procedure. NP it ends the procedure. End is the last instruction in all the program. It ends the source file. See, in all the program, first you have to write area which will make a new block of code or data. We are going to write instruction only, so it will make a block of code. Next to the area, we have to write session name. Session name can be anything related to our program. We can give any name. Next to the session name, we have to give which type of memory. There are three types of memory: program or code memory, data memory, and stack memory. Instruction will be stored in code memory only, so we will write code COD. Next to the code, we have to specify which type of memory that is. Code memory is which type of memory, whether it is read only or read write. Code memory is always read only memory only, so we have to write read only. So we'll move to the first program. Program 1, write a program to multiply two 16-bit binary numbers. So here we are going to multiply two 16-bit binary numbers. But those binary numbers will be taken in the hexadecimal form. You can see here data 1 is taken as 0002, data 2 is taken as 0004. We will multiply data 1 and data 2, we will get 0008. This will be stored in another register. So for this, we have to write now the assembly instructions. You see the program. First area. Next to the area multiplies. This is the session name. Next to code type of memory, and code memory is read only memory. So you have to write read only. Next entry is the entry point of the program. Next we are starting the program. Move R1 comma hash 0002. Hash means this data is immediate data. So this immediate data moves to R1 register. After this execution, we can find 02 data in R1 register. Next, data 2 is 0004 that moves to R2 register. The third instruction is for multiply R3 comma R1 R2. Multiply instruction will be having three operands. These are the three operands. First two operands will be holding the data. Third operand is used to store the result. So R1, R2 will be multiplied and the result will be stored in R3 register. Next NOP is nothing but no operation instruction. It does nothing, it is used for timing purpose, it is used like delay. Next end, it ends the source file. So these are about explanation. Now we'll see the simulation output. I open the tail window. First step is project. If any old project is there, you have to click on close project. Next, new microvision project. Select desktop. Inside the desktop, we have to create a new folder. I am giving file name program, folder name program 1. Inside the folder, file name program 1. Next, we have to choose NXP LPC2148. This is our ARM number. Okay, yes. Now, file new. Two windows. This is called project window. This is called editor window. Here only you have to type your program. Make sure that all the directories should start here, and with one tab you can type your codes. So after typing the program, you have to save your file. File, save. While saving, you have to give extension .asm because our program is assembly language program. Save. After saving, we have to add our program into the target. So click on this plus, then right click on source group, add existing files. This is our program. Next to file type you have to check. Ours is assembly source. It should not be C source, it should be assembly source. Then add close. Now you can check. It is added here. One more file will be created. Starter file will be created here automatically. We have to delete this for all assembly codes. So after doing all this, you can save once again. Then you can build our project. For that project, build target and see zero errors. Now you can debug our code. So go to debug. Okay. Okay. Now you can see here. See user system. Now the processor is in user system mode. In user system mode, we can there are these many registers R02, R12, R13, R14. R13 is stack pointer, R14 is link register, R15 is program counter, then CPs are current program status registers, saved program status register. These are the registers available in user system mode. If you want to check registers in fast interrupt mode, you can check R8 to R12, R13, 14 space. These all we studied in theory registers, ARM registers. Next in interrupt we have 1314 SPSR. In supervisor mode also 1314 SPSR. Abort mode also, in abort mode also 1314 SPSR. You can see here. Okay, now this is our program. Now you can see the program counter value. You can see everything is zero. All the register content, everything is zero here. This indicates the program, this instruction is being executed. So now to run the program, you have to click F11 or this you can click it. Okay. So it will execute each and every step by step. It will show the output here. So when we click the first, when we do the first click, see, we should find 2 in the R1 register because in the first instruction we are moving 2 to the R1 register. We can check, and the program counter it is 0 now. So it has to, when it is executing, when the ARM processor is executing this instruction, program counter should get the address of next instruction. Means it will show the address of next instruction. It is 0, so for the next time it will be 4. Means 0 plus 4. You can check. See, 2 is in R1 register, PC value became 4. So for the next time, it will become 8. 8 means 4 plus 8. So you can see, for the next click, 4 will be in R2 register and PC will be 8. 4 is R2, PC is 8. Next instruction multiply. We are multiplying R1 and R2. The result will be 8. That will be in R3 register. You can find 8 in R3 and this is C. Next instruction no operation. See, no changes will happen in any register, but PC is changing. That's all. So the 2, 4, 8. This is the result of multiply program.